Okay, we're going to start lab 1 for this CAD class. And to do so, the first thing we have to do, and realize now what I'm doing is I'm looking at the 2D drawing over here in this screen. I've got a 3D model already created. And then what we're going to do over in this graphics here area right here is create the 3D model itself. So to get started, what we're going to have to do is hit the new button, and again you can type in Control N if you want, or you can go here for new, or you can go right here in the iPro and go to new as well. It's going to bring up a dialog box, and we're going to go to the standard.ipt. All of these three-dimensional parametric solids will be .ipt files. The IDW files are the two-dimensional version of that particular file. The standard IPN files are presentation files, which we'll be dealing with later. We also have sheet metal drawings and weldment drawings. And then the standard IAM is an assembly modeling file. So we'll double click the standard IPT, or you can click and hit OK. And we've got our new file started here. Now, one thing I would suggest that you probably would want to do first is go ahead and hit save, and save this file and give it a name, much like you would do if we were dealing with just a 2D drawing on paper. The first thing you want to do is put your name on it. So I've got a file already started, so I'm just going to click that, and I'm going to call it David Smith Lab 1. I have to say yes to overwrite that file. Now, the only problem with naming that first is once we did that, we got out of our first original sketch. So to get back into that, I'm going to right click and hit Edit Sketch. One thing I will caution you about is I'm not a big fan of having extra sketches that are not being used. So don't start a new sketch there. Just right click on that sketch and hit Edit Sketch. Okay, the first thing we have to do is decide on this model, how do we want to create the part? I'm suggesting to you that we have to go in here and draw this shape first. We're going to draw that shape, and then we're going to extrude that back. And you can see that's what's going on here. So we want to catch this face first. So we're going to draw on that front plane, and we're going to draw some lines. With parametric solids, we don't have to be real particular about how and where we draw these lines. We're going to define that as we go along with something called constraints, which will tie things down and will constrain as far as it will control the attitude, if you will, whether it's parallel, perpendicular, horizontal, vertical, and so on. We'll also put parametric dimensions on it, and that will control the size of those particular features. Now, one thing I would suggest is that when you draw this first line, you want that cursor to snap right to that green point down there. That is your model origin, and we really would like to have that tied to that particular location. I missed it, so I'm going to hit Escape. Come back and do that again. I'm going to grab right on the end point there. Okay, now I'm in good shape. And all I have to do, now notice that didn't turn out quite like I wanted it. It should have been on the bottom line there, but that's all right. I'll go ahead and keep sketching. And again, I don't have to be real careful about this, as I'm going to be able to control the way that works here in the end. So that thing is all discombobulated. So now what I'm going to do is I'm going to put some constraints on there. So I'll right click, I'll hit Create Constraint, and I want that first line to be horizontal. So I'll grab that line, and notice it's snapped down there horizontal. And also I got this line went magenta and this line went magenta. Well, if I right click and hit show all constraints, this line went horizontal, and when it did, the fact that these two lines were perpendicular to each other already means that this one's now going to be vertical. They also were attached to the origin of the model, so that's kind of handy from that perspective. So I'll hide those constraints again. This line right here needs to be parallel to that or perpendicular to this. Doesn't really matter how you do that. We can go parallel from here to here. Okay. Then we need to put some dimensions on there based on the drawing. I can right click and hit create dimension. I can also come up here and hit dimension, or I can type in a D. Doesn't matter. Try to put the longest dimensions in first. 4.375. If you don't, it's liable to create a problem with the dimension might actually pull this line inside of this one, and that would be a little bit of a problem. We can adjust it, but keep in mind, if I'm not in a dimension here, I can move this line and it will move to wherever I want it to. The fact that this line and this line had the coincident endpoints means that if I grab one of these, the other one will adjust with it. So I'm going to create some more dimensions. I know the overall height of this thing needs to be 1.625. Okay, and obviously I've got this line is probably collinear, although no, it doesn't act like it is actually, because this line, if it was collinear to this line, they would both be magenta at this point. But I will go here and put this dimension in, and that is 0.4375. Up, there we go. Now they're not lined up, so we will want to get those lined back up here eventually. This line is 1.125 long. And again, you could go to the line, or you could get this line here to that line there. Needs to be 2.5625. Okay, and the only other thing, notice down at the bottom right hand corner, it says I need one dimension, or I'm going to hit right click and done, so I'm done with the dimensions, and I'll right click again and hit create constraint, collinear, and I want this line and this line to be along the same line, if you will, on the, in other words, have the same Y value for their height. Also note now that that part is fully constrained. So now what I can do is finish the sketch. I can go right up here and hit the finish sketch, or I can right click and hit finish sketch. And don't be too concerned with where your dimensions are located here. I know when we get done with the drawing, we want them to be in a certain location, but we'll move those as needed. So now I'm going to F4 function key and rotate that around so we'll be able to see this thing as we extrude it. And up here in the upper left hand corner, I can hit extrude. Now, the first profile, you don't have to worry about picking the profile that you want to extrude. There's only one there. Later on, when we have the 3D solid, we'll be able to pick different profiles, so we'll have to be more specific. We also can't do any of these Boolean operations. We can't do a join, a cut, or an intersect, because there's nothing to cut or intersect with. So for that reason, those are all grayed out. Another thing we need to note is the output. It is a solid right now, or it could be a surface. We want to stick with solids for now. Our distance back, according to this drawing, is 2.625. Okay, so if it's 2.625 in the distance here, I need to put 2.625, and you can see it automatically updates. Now, personally, I want this green box, if you will, that plane that we created the sketch on, to be out front. So I'm going to come over here and flip this direction. And we can see that solid now, and then simply all we have to hit is OK. And we now have our solid. The next thing I would like to do is go ahead and put in the V shape here. So it'll be on this face right here. The V shape is defined right in this view right here. Again, I right click and I can hold that left mouse button down and move it down or up to zoom. Right click and hit pan, and I can hold that middle mouse, or excuse me, the left mouse button down and pan, and I can just keep zooming and panning back and forth till I get what I want here. And it's that left mouse button, and then right click and done. Okay, so I'm going to create that V shape, and to do that I need to actually create a sketch plane on that green face. Now I can leave that green and hit create 2D sketch, and it will automatically jump to that, or I can hit 2D sketch, pick the face, and we're ready to start drawing that now. What I like to do is go to that view and look straight in on that view, and I'll draw some lines here to make that triangle or something similar to what I want there. The only thing that's necessary is the fact that these lines have to be coincident on their endpoints. In other words, the endpoints have to meet. Now what I can do is add some dimensions and constraints. I need a dimension for this line, and I need that to be 0.625. I need a distance from this end to this edge of 1 inch. I need the angle. Now angles, when you're doing an angle, you want to go and grab the more towards the center of the line. Don't grab the endpoints. And that's 45. I want to grab this line and this line like so, and make that 90. Done. Now, what happened here is our dimension jumped from going from this line to this line, from this line around to that line. And either way, I can go in there and delete that if I want, and put a new dimension in. So I'll go ahead and put a dimension again from this line to this line. So it's all about the position that you placed it. And I'm good with that. Now, obviously it's too high. And if I put a dimension on that, what you might see is if I went from this endpoint here to this line, problem is if I put in 0.3125 like the drawing says, it's actually above it. So that won't work for me. So what I want to do is I've got two different options. I can grab this thing and take it down below it. Again, my dimension just moved again. And I could go create dimension and go from this point here to this line. And you can see now it's going to go ahead and let me put that in there. That's really not what I want to do on this one. What I want to do is I want to create a constraint of coincident, and I want it to be, excuse me, I wanted collinear, I'm sorry. Collinear, this line to that line. And we see now that it's fully constrained, and 135 or 45, doesn't much matter there. And everything's good to go on that V shape. Right click, finish the sketch. Again, F4 function key, I'm going to rotate that around. I'm going to right click and do the zoom thing again. Whoops. I don't have my zoom on there, so what I'm going to do is I'll use the wheel to roll that towards me to get it closer. And I'll hold that wheel down to pan. So hold the wheel down, move your mouse left or right, up and down. That pans it for you. Push the wheel away from you. The picture goes farther away. Pull the wheel towards you. The picture comes closer to you. Okay, then what we're going to do is do an extrude. Okay, now I have to pick the profile because, as you can see, I've got this big profile. I've got this one, and I've got that one. Okay, it's starting to shoot out this direction, and that's because it was in join mode by default. I want to hit cut, again, that Boolean operation. Once I do that, it flips the direction. Now, it remembered my 2.625 distance that I had before, and I could type in a value. However, I don't know what the length of that object is. I don't need to know. What I need to do is I need to make sure that when I cut this V shape, it goes all the way to the end of this face. So I'm going to go, instead of distance, I'm going to use 2, and I'm going to pick this face right here. Once I've done that, notice the V shape cutout stops right at that location. I can hit OK, and I now have that cut. The advantage here is this. If I go back to this original sketch, which is this sketch right here, and I edit that sketch, and I change, let's say, this 2.6 or 2.5625 to just 2 inches, and I right click and finish the sketch, you'll note that that V shape grew with it because it had to go to the end of this face. If I had made that 1 inch or whatever that distance was originally, I would have an area here that would not be cut because this grew, but the V shape was not allowed to grow. So you have to be a little bit aware of what your design intent is, and make it so that the person that may have to work on your files down the road can make adjustments easily. 1 step instead of 2 here. Another thing I need to do right now is hit the save button. I've done some things here that need to be saved. Okay. I think the last thing we'll do then is, for this particular portion of the lab, is go ahead and put in the hole here, and then we'll call this lab, or this portion of that lab, complete, and we'll start another video. Before we do that, though, I do want to point out that you can name those extrusions different names. I might want to say front shape, and then on the second extrusion, if I click those twice, I might want to say V cut, so that I can intuitively, I have a way of knowing where those different shapes are and what they are, instead of just extrusion 1, extrusion 2, and so on. So I'm going to hit the save button again. Now, for this particular hole, we need to, here's all my information about that. It's located from the top front edge and from this left, or the left edge of that cutout, and it is a threaded hole. It's a 3/8/16 UNC 2B. Okay, that means it's got a 3/8 inch major diameter. It's got 16 threads per inch. The type of thread is unified. It is coarse, and it's a 2B class of fit. Note that this diameter of 0.3125 is actually the tap drill size. You do not have to put that into the information that we're going to use to put this hole in. So keep that in mind. So the first thing we have to do is come up here to the top and pick the hole command. This particular one is going to be put in linear from 2 edges. The first thing it wants to know is pick the face. And again, If I look down here below the cursor now in the lower left-hand corner of the screen, notice it says select a planar face or work plane as a placement plane. So I'm going to pick this face right here. There we go. It comes up and there's my hole. The first thing it wants to know is what edge do you want to come from? And again, it says select linear edge down in the lower left-hand corner. I want this edge right here. And that says I need 1.1325 from that edge. So I'll come back over here. 1.3125. And it locates that. And then I need to come from this edge right here. And that needs to be 0.5625 right here. 625. And we've got the location then and the face that it originates from on there. Now, we want that termination to be through all. So it'll go all the way through the part. And then we want, this is going to be a threaded hole, so we have to go tapped holes. Okay, and it's a unified national. So there's the unified screw thread. It's not ANSI metric, it's not isometric, it's not a pipe thread. It is unified